Welcome back, everyone. Look, if you're seriously aiming to absolutely crush your 2027 board exams, you are in exactly the right place today. We're locking down a massively important chapter. Consider this single ICSE MasterClass one-shot explainer as your ultimate, uncompromised vault for securing maximum marks in the Soil Resources chapter. We're not just going to sit here reading textbooks. No way. We are going to reverse engineer the exam to guarantee you walk away with total, absolute mastery. Let's get into it.
Okay, here's our syllabus roadmap for today. 1. The score maximizer hook. 2. Our exhaustive topic breakdown. 3. Erosion and conservation tactics. 4. High priority targets and PYQs. And finally, number 5, the Masterclass Vault.
All right, let's jump straight into Section 1, the score maximizer hook.
So, our ruthless, uncompromised goal today is simple, right? We're reverse engineering the geography paper for absolute syllabus mastery. And to guarantee those top scores, you need the right tools. I need you to subscribe to ICSE MasterClass right now and join our official Telegram channel. That's literally where you're going to download the free PDF notes and practice sheets that go perfectly with this exact explainer. Go ahead and do it now, secure your resources, and let's get to work.
Moving right along to Section 2, exhaustive topic breakdown.
Okay, we're systematically dismantling these core topics, starting with how soil is actually born. Now, the absolute crucial point here is pedogenesis. That's the scientific term for soil formation. And a quick fun fact for you, it can actually take up to 1,000 years just to form a single inch of this topsoil. Crazy, right? Before your exam, listen closely. Examiners are looking for very specific, non-negotiable keywords. Soil forms through the breaking up of, quote, parent rock over time, and it mixes with decayed organic matter, or humus. If they ask you to define pedogenesis, do not leave those keywords out. It's an easy mark if you just remember them.
Now, examiners frequently test the difference between how soils actually end up where they are. So you've got in situ, which means residual soil. This is soil that forms in its original position directly over the parent rock. Think of black or red soil for this one. Then you contrast that with ex situ, or transported soil. These are soils like alluvial, which get carried by rivers or wind and then deposited far, far away from where they originally formed. Make sure you keep this distinction locked in your mind.
All right, let's look specifically at alluvial soil, which, as we just said, is an ex situ soil. Guys, this is a massive favorite for board questions. You absolutely must know the exact differentiate between table for alluvial soil. So you have young Cotter soil versus old Bungar soil. Cotter is the newer, finer, lighter-colored alluvium. It's highly fertile, and you'll find it in the lower plains. Bungar, on the other hand, is the older, coarser soil found higher up. It often contains conker or lime nodules, and it's definitely less fertile. You want to replicate this exact comparison word for word in your board answers.
Let's rapid-fire the overall properties of alluvial soil. Remember, it's ex situ, transported primarily by the massive Indus, Ganga, and Brahmaputra rivers up in the north and the delta rivers down in the south. It's huge, covering 40% of India's total area. Chemically, it's really rich in potash and humus, but it's deficient in nitrogen. Because it is so incredibly fertile and easily tillable, it's literally the absolute ideal soil for growing wheat, rice, and sugarcane.
Moving on, we see this next direct comparison all the time in exams. They love to contrast the transported alluvial plains with the in-situ volcanic black soil of the Deccan Plateau. So alluvial is river-transported and light, while black soil is formed by the weathering of basaltic lava rocks and is intensely clay. Knowing these exact differences basically hands you the perfect answer format for a 2-mark differentiation question. Don't miss out on those easy points.
Let's drill down into the highly tested give reason keywords for black soil, which is also known as Rager soil. Formed from basaltic lava, its absolute most unique feature is that it's self-plowing. What does that mean? Well, during dry seasons, it essentially breathes by developing these really deep cracks, which allows for massive air circulation. Plus, because of its high clay content, it acts almost like a living sponge. It's highly retentive of moisture. It just holds onto water so tightly, making it the perfect environment for cultivating cotton.
Next up, we're deploying another critical differentiation point: red soil versus laterite soil. Now yes, both of these are red in color because they have iron oxide in them, but they differ entirely in their formation process and their fertility. Treating them as the same thing is a massive mistake. Let's break them down individually.
Let's start with red soil. This one forms through the prolonged weathering of ancient crystalline and metamorphic rocks. It's highly porous and loose, meaning it really doesn't retain moisture well at all. And because it totally lacks humus and nitrogen, it absolutely requires irrigation and fertilizers to be productive. Here's a direct identification question for you. When the board asks you to name the soil ideal for dry farming, your definitive answer is red soil. It's perfect for crops like groundnuts and millets.
Now for laterite soil. We're going to break down its pedogenesis into specific steps, heavily emphasizing one totally non-negotiable keyword here: leaching. So laterite forms in areas with heavy tropical rainfall and alternating dry and wet periods. This extreme weather causes intense leaching. Basically, the heavy rains literally wash the silica and soluble nutrients deep down into the ground, and it leaves only this hard and fertile crust of iron and aluminum oxides behind on top.
All right, that brings us to Section 3, Erosion and Conservation Tactics.
We've talked about how soil is actually formed, but examiners also demand that you understand the destruction of the topsoil. Here are the precise causes of soil erosion that you've got to be able to rapid-fire for a standard 2-mark geography question. The agents of erosion are water, which causes sheet, rill, or deep gully erosion; wind, causing denudation, especially in arid regions like Rajasthan; and of course human activity, which is a massive factor. Think about deforestation, uncontrolled overgrazing by cattle, and faulty farming techniques.
So how do we actually stop water erosion? Look at this large-scale infrastructure here. By constructing massive concrete dams and spillway gates across our rivers, we can check the devastating speed and force of the water flow. This effectively prevents catastrophic flood-based soil erosion down in the lower basins. It's a real game changer.
You also need to distinguish between these critical agricultural conservation techniques to really secure your marks. Terrace farming involves cutting flat steps into hilly slopes, and these act as bunds against the water. Then there's contour plowing, which is plowing at right angles to the natural slope of the land so you catch the water in furrows. And finally, shelter belts. These are rows of trees planted specifically to break the force of the wind, essentially stopping wind erosion right in its tracks.
Let's pivot to Section 4, High-Priority Targets and PYQs.
Okay, now we pivot from foundational knowledge straight into predictive strategy. First, we're pinpointing the high-priority map-marking regions that statistically carry the highest curriculum weightage for 2027. You have to know exactly where these are. Alluvial soil dominates the northern plains and east coast deltas. Black soil covers the Deccan Plateau, primarily in Maharashtra and Gujarat. Red soil is super expansive across the south in Odisha. And laterite soil, you'll find that in very specific high rainfall patches right along the western and eastern Ghats. Memorize these zones, guys, for sure.
Next up, let's brilliantly contrast these two massive give reason past year questions to ensure you have total conceptual clarity. Number 1, why is black soil self-plowing? Because its heavy clay content retains moisture and it develops deep cracks during the dry season, essentially aerating itself. On the flip side, why is laterite totally infertile? Simply because of intense leaching. The heavy rains just wash all the vital nutrients like silica deep below the topsoil, leaving nothing good behind.
And here's another very frequently asked board question. Why does red soil require irrigation support and heavy fertilizers for cultivation? Pragmatically, it's just because red soil is structurally highly porous and loose. Water literally just drains right through it. Plus, it's naturally deficient in vital nutrients like nitrogen and humus. So, without heavy human intervention, it simply cannot support demanding crops.
And finally, Section 5, the MasterClass Vault. Well, we've covered the critical data, the exact terminology, and the specific angles the examiners are going to use against you. Your final step for complete syllabus mastery is right on the screen. Subscribe to ICSE MasterClass right now and join our official Telegram channel for your free PDF notes. Lock in your resources today. But before you go, ask yourself this. As our population grows and our demand for food skyrockets, will the soil beneath our feet outlast our generation's footprint? Think about that, and I'll see you in the next explainer.